Just to give you a quick idea of the scale that we operate on at Walmart, I'm sure many of you have heard about the company Walmart. So Walmart employs around 2.3 million associates, and we serve around 270 million customers on a weekly basis. And we do this through over 11,000 stores that we have, and various e-commerce systems. And all of this is operating in 28 countries. So you can imagine that even when we're kind of planning to roll out some internal application that is supposed to cater our own internal associates, we're already having to deal with considerable scale. So that's quite interesting from a platform perspective, especially. The other thing that's also very interesting is the fact that Walmart has this kind of two different kind of landscapes. One is these kind of large-scale clusters that we're operating in the cloud, and then we also have many kind of smaller edge clusters that are all operating in our stores and our distribution centers. So again, for a platform engineer, this is quite interesting. Now, I'm sure you're not here to listen to me talk about how awesome engineering at Walmart is. So let's just dive into the actual theme of this presentation. So once upon a time, there was a monolith, perhaps multiple. And of course, this monolith was beautifully architected. It made our life so great and fulfilled so many business values. And of course, my slides, by the way, are an oversimplification of orders of magnitude. But essentially, this monolith was very modular. We had various modules inside of this thing. And these modules would essentially communicate with each other to fulfill whatever responsibilities they had. And the invocation between modules was some form of in-memory invocation, function calls or method calls. And generally, this actually brought us a pretty long way. Until, of course, a certain threshold was breached. And we woke up one day and we realized, well, the size of the code base, the complexity of the overall system, the scalability challenges that we're facing, and in general, the whole development velocity is definitely not where it's supposed to be anymore. And so, we did the obvious thing. And, at the time, we referred to it as, introducing a service-oriented architecture. Today, we kind of talk about it as, or refer to it as, a microservices architecture. We broke up the monolith and decomposed it into individual services. So in a simplified sense, essentially, we took all of those modules and made them individual services. And, with these individual services, we're able to kind of develop them individually, scale them individually, and maintain them better. Of course, we had to change our whole engineering culture at the company. But life was much better now, and velocity came back. However, of course, by solving the kind of old set of problems that we had with the monolith, now all of a sudden we had a brand new set of challenges that we had to solve with this new architecture. One of the things is, for example, the act of service invocation is all of a sudden very different. Like these arrows in between the services become much more critical and important, and we have to very much focus on them. Whereas in a monolith, when a module invokes another module, essentially it's usually a simple matter of preparing a stack and having the CPU jump to a particular instruction. Now all of a sudden we need to actually traverse the network. And this is something obviously that can fail often. And so we need some type of resiliency. Also, how do all of these services discover each other? Like how does A know where to find service B? And if service B kind of changes its whereabouts, how does service A get notified of that? And how do we even observe this overall kind of large system? How do we know what's going on at any point in time with our kind of larger infrastructure? And debugging, how do we even debug and trace kind of problems? How do we pinpoint, the particular source of any problem that we're facing in production? And of course, orchestration, now that we're kind of invoking services, via remote calls, somehow we need some type of governance so everything is done appropriately, and we need some type of policy enforcement. So we have all of these new challenges. And again, we were quite early to this, and the first solution to this new set of challenges was to kind of introduce some type of centralized intermediary. And you can think of an enterprise service bus or some type of API gateway of sorts. And the idea was pretty simple. Essentially, instead of having all the services directly talk to each other and instantiate kind of point-to-point connections, now what they do is they kind of talk through this centralized intermediary. And it would take care of things like discovery and routing and resiliency and policy enforcement and observability and you name it. It was all there to a certain extent. And yeah, that certainly solved the problems that we had, when we kind of naively decomposed our monolith into, individual microservices. But of course, once again, having solved, the current set of problems, we have now introduced a brand new set of problems. With this particular architecture, some of the most important things is the fact that we've introduced the single point of failure, right? Since all of the services are relying on this, kind of centralized broker or intermediary of sorts to communicate with each other. If this thing goes down, obviously, no one can communicate with each other, and we have a problem. In addition, we also introduced kind of a different form of scalability challenges, because as our microservices architecture is growing, and of course, at Walmart, we went from, dozens to hundreds to thousands of services now. We have, this centralized kind of system has to account for the additional load and throughput and overall weight that is put on the system. So we as a platform team have to kind of constantly maintain, monitor this thing and kind of keep scaling it up as the usage of it grows. Of course, the latency story isn't all that great either here, because when we decomposed the monolith, of course, and we introduced remote invocations, all of a sudden, our latencies went, from in-memory to kind of remote calls, that kind of deteriorated the kind of performance with orders of magnitude. Now, all of a sudden, we're actually doing multiple hops on the network, which is definitely not a great thing for performance overall. And from a kind of platform perspective, as we're trying to kind of innovate and improve the overall kind of platform, whenever we're looking to kind of make changes or add new features or even fix bugs at runtime, we have to be very careful, because any change we do in this kind of centralized system is impacting all of the tenants at the same time. So that is kind of very tricky, and at some point, our kind of the velocity of our improvements comes to a grinding halt. And so, we obviously recognize that the fact that these problems that we're now facing are due to the fact that we have this kind of centralized nature, or our solution has been centralized, and that's kind of the culprit of these particular problems. So the obvious kind of next step is to take that centralized solution and decentralize it. So at the time, the thing that we came up with was to kind of create a, let's call it a microservices framework of sorts, essentially like a framework or a set of libraries that take care of all of the same concerns that the centralized system was doing. The same kind of routing and discovery and resiliency, et cetera, et cetera. And thereby we would kind of have this framework take care of all of those requirements, and we would eliminate the need of this centralized system. Now, this certainly kind of solved all of those problems we had at that point in time. But once again, we've kind of changed the architecture. And we went from an old set of problems, and now all of a sudden we have a brand new set of problems once again. The problems that we're facing now, for example, is the fact that this particular solution is non-polyglot. Now, in the case of Walmart, our engineering teams are free to use whatever technology they would like to use and that they feel is the best fit for their kind of use cases. So you will find any language, any framework, any set of libraries being utilized in our company. And we as a platform team somehow have to facilitate these kind of platform concerns to, for all of these technology stacks, which in this particular architecture essentially boils down to us having to kind of port this microservices framework to all of the different technology stacks, which is definitely quite the overhead on our team. In addition, the actual kind of microservice framework now is all of a sudden hard-coded into the application. So your platform is now, a part of the actual applications, and thereby this makes kind of, changes very difficult, because again, if we're trying to innovate, improve the platform, add new features, and fix new bugs, we have to, in this architecture, go to each and every application team and essentially beg them to kind of upgrade to the latest and greatest, which also makes things extremely challenging in practice for us. And of course, enforcement of appropriate usage of this framework is also quite tricky. I suppose the question here is there a middle ground, right? Between the centralized solution that we had and the kind of more distributed solution using frameworks, where we don't have the centralized kind of problems going on, is there something that would give us the best of both worlds, and without kind of the problems that come with these two kind of architectural patterns? And essentially, the answer to that question presented itself with the introduction, or at least the introduction for us, to the sidecar pattern. So when we learned about this particular pattern, we were extremely excited, because we immediately recognized that this pattern would be essentially the next step in kind of evolving our overall architecture, especially as a platform team. And the idea is pretty simple. We essentially take, again, whatever the microservices framework was doing, or that centralized kind of solution, and we extract that into a sidecar proxy. And that sidecar proxy would facilitate the same use cases and requirements, but no longer be actually hard-coded in the application, while still maintaining that decentralized kind of characteristic. And so this solution is beautiful because it's transparent, it's fully polyglot, we only have to implement it once, we don't need to port it to all of the different technology stacks, it's fully decentralized, and it's also efficient because we're not adding those kind of multiple remote hops on the network. So very excited to kind of start implementing this thing. And as we start kind of thinking about, okay, how do we get sidecars onto each and every workload that we're running? The first thing you realize is, well, obviously somehow we'll have to kind of, manage and maintain the operational semantics of each and every sidecar that we have in our architecture, right? So we need to kind of be able to dynamically configure these things and change how they behave, as the conditions of our overall system are changing. And so, obviously we need some type of control plane to manage all of this. And so this is kind of the architecture, or the architectural idea that we landed on. And up until thus far, I've only shown you kind of general patterns and boxes and arrows. I suppose the big question now is, okay, how do we go about actually implementing this? What are the ready kind of solutions that we could employ to get, some architecture like this to kind of work for us? And so we're actually in a very luxury type of position, because in this day and age there are many different types of service meshes that one can kind of choose from to kind of realize this particular architecture. Now, for us, since we were very early to the game with this particular kind of solution, we essentially adopted the first service mesh that came out, at least that we knew of, and that was Linkerd. So Linkerd kind of brought about this kind of revolution in thinking with regards to kind of handling platform concerns in a sidecar. And we were very quick to kind of start to kind of think about, how do we bring it into our architecture? What do we need to do to make this thing a reality? And so, us being Walmart, obviously, we're not a startup. We can't just take something that is ready and just think, it's just going to work for us. We need to integrate it into a larger pre-existing architecture. And so we already had systems that, for service registration and identity management, for cloud configuration, and a system for telemetry and alerting, and you name it, which was essentially our kind of de facto control plane. And, the beautiful thing about Linkerd is the fact that it's quite modular, and we could kind of extend it and implement plugins. So that's what we did. We implemented a whole bunch of plugins, integrated into our existing ecosystem in the pre-existing architecture, and we essentially hit the ground running. Now, the other interesting thing is that we were also able to implement a policy engine, or actually we ported the existing policy engine that we also had in the previous solutions, and now had that execute in Linkerd directly in the sidecar. So we even had a transparent backward compatible solution for this kind of next generation architecture. Now, again, us being Walmart and having this kind of diverse landscape of technologies and use cases and requirements and immense scale, there's always room for different solutions to coexist. And so at this point, we're also thinking about or going forward with adopting Istio as a service mesh. And Istio is actually quite beautiful as well, very modular, and we're doing the same kind of exercise with integrating it into our kind of pre-existing architecture. And what you see here on the picture doesn't really depict the integrations that we've done, because I don't really have enough time to kind of go into detail about that, so feel free to kind of reach out to me after the talk. But essentially, you'll notice kind of a pretty much default setup with Istio, minus a couple of subtle differences. So for one, we're not leveraging the egress gateway at this point. We've kind of offloaded its kind of concerns onto the sidecars directly. And the other thing is that we decided not to use the policy mixer, which essentially means that we're not leveraging the native policy enforcement that Istio provides. And that's for the reason because we have our own policy engine. And we need to be backward compatible once again with all of this pre-existing architecture. And so therefore, we essentially started off actually with implementing an external mixer adapter. But since our policies are not really properly cacheable, doing remote policy enforcement is quite expensive, and the latencies numbers weren't really where we wanted them to be. However, Istio and Envoy have this kind of awesome thing where essentially there's some type of JIT compiler inside of Envoy. So you can kind of send Lua scripts to Envoy, and then thereby have it kind of execute any additional semantics that you want. And so what we ended up doing is kind of porting our existing policy engine to Lua, and essentially leveraging that to get the same kind of transparent, backward compatible setup, but now with Istio. So there's that. So now, if there's one thing I'd like you to take away from at least my part of this particular talk, is the fact that as we've kind of been evolving our architecture and making steps into kind of introducing new patterns and everything, essentially, the commonality is that with every improvement we make, we're taking an old set of problems and solving them, but thereby introducing a brand new set of problems. And so we're under no illusion that the service mesh is some type of silver bullet that solves all problems for ages to come, right? Clearly, there will be a brand new set of challenges which will take things to the next level. Now, what are those next set? What is that next set of kind of challenges? I have some ideas. I don't know exactly yet. Perhaps I'll have an answer next year. But we're very excited with this kind of new evolution, especially as a platform team. So with that, I will thank you for your attention, and please give a warm welcome to Projecta.
So thank you, Georgie. And I think Georgie said it really well. We have to make sure that we solve the challenges that you face as you bring in all of these new technologies. So Georgie, let me tell you about a set of challenges I keep hearing from Google Cloud customers. And that's, like Georgie mentioned, a very nice pattern on how they went to the service mesh. Similarly, we have questions from customers that how do I go and bring service mesh into my brownfield? Or how do I go and containerize into my existing brownfield deployment? Because if you really think of the customer, they don't really care about service mesh. They're not really caring about containers. What they're really asking for is infrastructure and data scalability. They want smaller, independent development teams. They want to ship faster. And they want to keep or deploy services wherever they want, but they want to manage all of these uniformly. And they definitely don't want to build the services management infrastructure or manage it. And they want to migrate from their starting point at their pace. So there are 4 transformational technologies that I keep hearing customers ask on how to bring into their brownfield: microservices, containerization, service mesh, and serverless. We have several different patterns. I'm going to talk about 1 or 2 patterns on how customers do this. But one frequent question I hear is, should I mesh first or should I containerize first? And I'm going to describe 2 different approaches. These are inspired by our 2 real-world customers on how they actually did it or how they're thinking of doing it. Let's talk about customer A. Now, their strategy is to mesh first and then containerize. Why is that? So one thing I want to actually say before even we deep dive into customer A is that there is a very common misconception that service mesh is for containerized services. And actually, that's not true. So let's look at our customer A. This is a pretty big customer. They started their journey to Google Cloud a few years back, and they had one big monolith, and then they chopped it up. So it went to 20 microservices, then they got it to Google Cloud, they chopped it up further, they got 80 microservices. They were able to get the agility that you get with microservices, but there's a problem too. Because they went from managing one monolith to going and managing hundreds of services. And so in their set of goals, getting a way to go manage these seamlessly, easily, uniformly was much higher than going and containerizing them first. And so they said, we'll go and adopt the service mesh first, and then we will containerize. And obviously, if you think of it, if you went and containerized a monolith, you probably wouldn't get much anyways. So what was their blueprint? What did they do? The starting point was a VM-based set of services. Obviously, this is just a very small subset of what services they ran. Then they added the sidecar proxy to their VM-based services. They also deployed an ingress. Now, ingress is a very critical part of service mesh because that is where you're guarding the entry point to your mesh, and you want it to provide DDoS defense. You want it to be very robust because that is where a lot of your external traffic comes and hits. And so they had an ingress to provide a secure and programmable entry point to their mesh. And then they layered in the service mesh control plane. And then they moved some of their services from VMs to containers, and they lived happily ever after. At this point, you should be asking me, but how? So let's take a step back, and let's see how they actually did it. Now, every customer has a strategy generally when they do this type of transition or transformation. And one of the strategies that customer A had was to go with managed services wherever possible. And this was simply so that they could make the move faster without having the expertise in-house to go manage the infrastructure or even build it. So they had 4 main considerations. What do I go and use for container management? What do I do with the service mesh control plane? Where do I get that as a managed service? Where do I get an Envoy image from? And then who manages the Envoy lifecycle? Because that's one of the frequent questions we get as well. So here is the approach they took. Essentially, for container orchestration, they use GKE, which is Google Kubernetes Engine. For the service mesh traffic control plane, they are planning to use Traffic Director, which just went beta yesterday. For the opinionated and certified image, they used an image from Tetrate. And then for the Envoy lifecycle management, they plan to use a Tetrate solution as well, and we'll talk about it shortly. So I'm not going to deep dive a lot into GKE because there are several excellent talks on it. I highly recommend watching them. But let's go to Traffic Director. So what exactly is Traffic Director? If you really think of adopting the service mesh, one is the transformation inside your organization, as Georgie spoke about. And then the second part of it is also having pieces in the control plane that are delivered to you as a service. And so that's why yesterday in Ur's keynote, we launched Traffic Director. It's our new GCP-managed service for the service mesh. And there's also a detailed talk on Traffic Director from yesterday. So here is what it does. First of all, imagine that you have your data plane that's comprised of your VM or container-based services. You go and inject your Envoy proxies in there, and then the Traffic Director becomes the control plane for it. It'll give you global load balancing. It'll offload the health checking from your Envoy instances. It'll also give you traffic-driven auto-scaling. It will also give you a bunch of traffic control capabilities, and if you already use Envoy, you're familiar with those. Canaries, traffic splitting, traffic steering, mirroring, circuit breaking, and so on. And the nice part is it's GCP managed, so you will get a production-grade SLA at GA. So it takes a lot of the toil out of going and managing this stuff. One of the key things that we emphasized when we built this out is it has to work for VMs and containers out of the box. So if you actually look at my example here, the first service is essentially self-managed Docker. The second one is a VM-based service, and then the third one is a Kubernetes Engine service. So it is able to manage all of these heterogeneous environments very seamlessly. And then you can have things like deploying your instances anywhere. That's what you get out of the global load balancer. And what that really means, so why is global load balancing important? The reason it is important is that, first of all, you don't need to configure anything to make that happen. All you do is create a service, put your instances in whichever part of GCP regions that makes sense for you or where your users are, and then you turn on Traffic Director. And what it will do is that if your service in region, let's say all of the instances for a service go down, when the traffic is coming to that region, it will seamlessly redirect it or overflow to another region. And you don't need any configuration to make that happen. That's implicitly built into the Traffic Director. there's another very interesting reason I brought up Traffic Director in this talk, which is how do you go make the transition from a VM-based service to containers? There is a construct called network endpoint groups, which I'll talk about. So imagine initially your service was sitting in the VM, and we have what is called managed instance group. That's where you specify all your VM endpoints, and then your service is essentially instantiated into that. Now, imagine you wanted to containerize that service. There's a construct called network endpoint groups. And so you go create a service one prime, and you add all of the container endpoints inside a network endpoint group. The network endpoint groups lets you see those individual containers, and so you can load balance to them, you can do traffic control to them individually. And so now what you do is you have a service, the same version of the service, which is in VM instances, and another one which is sitting in containers. And so you send traffic to both. You have control knobs, so you can say 99% goes here, 1% goes here, and so on and so forth. Once you do that, then what you do is you start draining your VM-based service. So slowly, you start shifting the traffic to your containers. And then eventually what you can do is you can drain away your VM-based service. And you can do all of this without disruption, which is why it's really huge from the point of migrating a given service from VMs to containers. And then this will get even easier because we have a plan to support both a managed instance group and a network endpoint group behind the same service. And so you don't even need to create another service. You just create a network endpoint group and then slowly migrate your traffic from the managed instance group to a network endpoint group. So it just gives you a very easy way to go from VMs to containers for a given service. The second part of the problem is, like, how do we go and manage the Envoy lifecycle? This is a question I get asked often, and I wanted to invite Dee from Tetrate to talk about some of the solutions they have in this space.
Hello, everyone. Hi, everyone. I'm Dee from Tetrate. I'm a software engineer at Tetrate. I'm very lucky to be here. I mean, thank you, Prajakta. So the question is how we do the Envoy lifecycle management. So the challenges with Envoy lifecycle management will be like, where do we get the Envoy binaries? I mean, getting the trusted and updated build of Envoy is not easy. I mean, like, building yourself probably will be a torture. And then there should be another one, like integrated vulnerability check and scanning, and how, if there is a fixes on upstream, how you get it. And then how do you exactly do that, upgrading your Envoy? So here at Tetrate, we do this some of tooling that do the initialization and do the continuous check in your infrastructure. And we do this out of the check, vulnerability check, and so on and so forth. And we also offer how to upgrade that. So here, this is the Get Envoy. Get Envoy is one of our products that we launch. It is still in preview, but we will do this build distribution of Envoy. It is trusted, it is certified, and there will be a mechanism on how to upgrade Envoy, and also how we do the integrated scanning for patching the Envoy. Okay, so Get Envoy by Tetrate will open the access of the build pipeline itself. It will be there for public, and we committed to work with the community, bringing tested Envoy build with low cost in your side. So we also work hard to integrate that our patching to upstream. So we also we have additional protocol support if you need it, and we have full attention support from maintainers inside Tetrate. So we have one senior maintainer in Tetrate, and for proxy, and another maintainer. So this is a case when you do the vulnerability scanning synthetic attack to do vulnerability scanning. One of this is synthetic attack. So basically, you do checking on. So we have Envoy built there in our local or in your environment, and then we do the synthetic attack on that, and we check if it is vulnerable or not. So this is this kind of a mechanism will be integrated. It can be standalone, or it can be integrated to your environment. So more than that, we also offer Envoy customization, because Probably you need that. So this is Envoy at its core is extensible. You can basically write your very own extension. In fact, this extensibility drives the adoption of Envoy. So this is an invitation for you to contribute to Envoy. You can check out Envoy on how to extend Envoy and stuff. So this is the integration with, well, when you get the Envoy from someone else, a third party like Tetrate, probably you want to ask, like, is it compatible with any control plane out there? So we do this integration with Google's Traffic Director and Apache SkyWalking for observability. So we have front end running in a VM, pointing to user service. At first, the user service points to profile service that runs on VM. And then after that, we gradually program Traffic Director to point to the profile service 2 on Kubernetes. So as projected shown to you, that we will drain the traffic from VM to Kubernetes by programming the Traffic Director. So this is a video of the demo. So first, we have two different services running deployed in Kubernetes and VM, and then we gradually apply the rules to the Traffic Director, so we can move from VM to Kubernetes. So as you see that here, once we implement the policy, the routing from VM to Kubernetes, we will see changes in the UI. So let's just wait. OK, so as you see that when we move the traffic from VM to Kubernetes, it will show a fix on the UI. It's 50-50 traffic. So I think that's all from me. I'll give it back to Prajakta. Thank you.
Thank you, Dee. And I think if you didn't see the hearts, they were changing between white and red. And so that was the 50-50 that was happening in there. So coming back to, so we spoke about customer A, and he showed us also how to go inject your envoys. And there's a bunch of capabilities they provide. But then there's a different type of customer too. So let's talk about customer B. This is a customer based out of APAC. And they had a different set of goals, which was let's containerize first, and then we will mesh. So how did they do it? It seems like the common theme is a monolith on-prem. I need to add some more blueprints where that's not always the case. But even this customer had a monolith that sat on-prem. And they said, we need to move to the cloud. While we move to the cloud, we also want to do some refactoring. And then we want to make sure that as our services move to cloud, they are more and more modern. And so that was their goal. Now, what is the strategy that they deployed? The first thing that they did actually is not much, in that they left the monolith on-prem, then they took Google's global load balancer, and then they put a set of API gateway instances behind that. And as you can see, each of these has a different purpose. So there's TLS termination, DDoS defense that they got out of the global load balancer. The API gateway obviously did API level routing. We have several products like Apache as well that you can use. Then you have, as you notice, they wanted to do everything in a way that their services got containerized as they moved to cloud. So you can see everything in Google Kubernetes Engine. Obviously, nothing has moved there yet. And then you have the monolith on-prem, and simply the traffic is coming in through the global load balancer, through your API gateway, and getting routed to on-prem. So again, no disruption till this point of time. Next, what they did is they took a chunk of a service out of the monolith. You can see service A, and then they put it on-prem. When they moved it, they containerized it. So when it was instantiated in Google Cloud, it was a containerized service that was managed with GKE, our Google Kubernetes Engine. Similarly, they got another service B. So you can see that the monolith has started to shrink, and then they got it into Google Cloud. That's your service B. For many of the services, they were able to rewrite the services to use gRPC. So in the event where you can do rewrites, I would highly recommend looking at gRPC as your transport interface. And where not, you can continue to use your HTTP and so on and so forth as well. Now, once they did that, there were some systems that, or some services that would never move to GCP. An example of this was a payment service. And they shared this payment service between various deployments, so they didn't want to move it to Google Cloud, but they still wanted all of the modernization for that service. So what they did is they chunked out that service, put it on-prem, that's what you see with Service C, and then what they did is they wanted to manage it using the same primitives as they do with GKE in Google Cloud. So they brought in GKE on-prem, and that is what they use to manage this service now, which is sitting on-prem. But the primitives are same, GKE in Google Cloud, GKE on-prem, and then they don't have to relearn 2 new primitives in each case. Now, obviously, one service sits in Google Cloud, another sits on-prem. They have to communicate. So now you need service-to-service communication, and that is what necessitated a look at the service mesh, and then some of these technologies about service-to-service communication. So what they did is they first injected the Envoy proxies, you can see on Service B and Service C, and then they managed that with Istio on-prem, and then they have an Istio control plane running in GCP as well. At this point of time, most people want to get out of running the control planes themselves. And so now with Traffic Director, in GCP side, they are going to manage the traffic control plane using Traffic Director. And then for the rest of the pieces, they'll continue to leverage Istio. And in the future, once we support a hybrid model where Traffic Director can manage instances on-prem, then they will do the same thing for the Istio, and then the Istio that is on-prem will remain as a fallback. So in case Traffic Director can't communicate with instances, it will fall back. If you really think of it, the next big innovation, or the next big, I wouldn't call it a challenge, I think it's an opportunity for innovation, is around federation of all of these control planes. And so you will see a lot of conversations around this, but this is essentially the thing that they deployed. And so if we had to summarize the steps, this is what it looks like. So they went from a monolith, and if you just go 1, 2, 3, 4, 5, 6, those are the steps that they took to get to a modern architecture. So in all of this, I know we spoke about a bunch of solutions. We had Georgie describe how Walmart does it. He described some of the solutions from Tetrade. We also have a bunch of solutions in Google Cloud. And one of the questions I often get asked by customers is, should we use Google Cloud products? Because they are best of breed, sure, but do they lock us in? And it's a very frequent question that I get. And my question always back to them is, what if you could get both? You get best of breed products, but there's also no lock-in. And the key to making that happen is essentially the open interfaces. So we'll talk a little bit more about that. But the first thing, so let's take a look at the migration tools. Here there is no lock-in because you're essentially using these to do possibly a one-time migration. I don't know how many of you attended the keynote, but if you did, you saw the announcement of a product called Anthos Migrate, and then it's at beta. It auto-migrates VMs from on-prem into GKE. And so there is very minimal effort on your end to do it. There's an excellent talk on it as well. And then what that means is when you use, and it's very holistic in its approach. So you can see it does discovery, migration, planning. There's a whole set of steps that it does to get your VMs into GKE in Google Cloud. And so what that means is your own folks can actually take the time and focus on managing your applications without really having to worry about how to do the migration and so on and so forth. Now, once you've migrated, or even when you're in GCP, the question is, what are the tools you should use and where should you worry about lock-in? So the answer is wherever you find an open interface, that is where you don't have to worry about lock-in. Because if you don't like something, you can swap it out as long as the interface is open. And I'll give you an example. Let's say you, as a starting point, you are our load balancing customers. You don't really care about the service mesh. You don't really care about Traffic Director initially. So you're looking for another flavor of L7 ILB or something like that. And then what you do is imagine that you suddenly now said, I want to go and modernize my load balancing, and so I want to go look at the service mesh. So there is a huge bunch of customers who start off as load balancing customers and then go and on to become service mesh customers. And in there, one of the nice things about Traffic Director is when it speaks to the Envoy, it uses XDS APIs, which is what the open interface used for any service mesh control plane that talks to Envoy is. And so if you don't like Traffic Director, you can swap it out. And it doesn't even have to be Envoy in your data plane, because as long as that proxy supports XDS, you could bring your own proxy, you could go customize Envoy, as long as you preserve that open interface. And so that's the track we are taking to ensure that there's no lock-in, while at the same time, we do want to take away the toil of managing these control planes. So if you, and actually there's another very interesting set of customers who are like, I want all of this modernization without having to worry about Traffic Director or Envoy. And they're like, okay, we have a service sitting which just I cannot go inject an Envoy in there. So what do I go do there? And so that is why we created another flavor called L7ILB. So it looks like any other load balancer to you. And so what you would do is you would get all of the benefits that you get from traffic control and other primitives from Istio and Envoy, but you don't necessarily need to even worry about a control plane or a data plane or running envoys. It just looks like any other middle proxy to you, and you take it and you put it in front of your services. What it really looks like under the hood is this. So it is Traffic Director, which is managing a pool of envoys for you, but it's abstracting all of this out and just making it look like any middle proxy to you. So it's which technologies you adopt and which sequence is a function of the skill set that you have in your folks, or what your goals are, or what is the strategy you want to start with, what other considerations do you have in terms of cost, time, and so on. And once you've nailed that down, then it gets easier to start picking one or more of these technologies. There's another set of customers who actually is not from the load balancing pool. Now, they come in from the point of view of saying, I have these multi-cloud services, or I have microservices, and I want to go and consistently and uniformly manage them. And so they're probably already GKE customers, or they may be looking at GKE. Several of these might have used Envoy in various forms and shapes. Many of them may be open source Istio users. And so that is where, again, you have a whole slew of options in here, ranging from open source to Google managed. And the key in each of these, so like whether you use self-managed Kubernetes, or whether you use our GKE, or whether you use GKE on-prem, it's the same set of APIs and primitives, which means you don't get locked in. You can switch between each of these. Similarly, if you use Traffic Director, or you use Istio to talk to Envoy, or you have your homegrown control plane that talks XDS v2, you don't get locked in, because you have the capability to go and switch, because the APIs and the interfaces are open. And then there's another one which I think we don't talk about enough, which is gRPC. If you have services that are using HTTP 1.1, etc., and you want to bring in HTTP2 as an example, then you bring in HTTP2, you would bring in gRPC, and so on. If you have services that you cannot rewrite, then you can keep it as a goal and save it up for your phase 2. Then the next thing which I often get asked, so all of these, but there is a set of people who don't want to see any infrastructure at all, whether it's service management infrastructure, whether it's container orchestration, and so on. And that is where really, if you were there yesterday or day before, you heard about Cloud Run. That's essentially serverless. And again, the same question, like, do we get locked into your solutions? And the answer is no. Because if you look at it, first there's Cloud Run. So it's fully managed. You deploy your workloads. You don't see the cluster. It's fully managed service for you. But then I have a GKE cluster. So then you go and use Cloud Run on GKE. And then what that lets you do is you run the serverless side by side your containers or your existing workloads, and then it runs seamlessly. But then a lot of you also have on-prem or other deployments of Kubernetes. And then you are like, what about Cloud Run there? And so that's what Knative lets you do. I don't know how many of you attended all of these talks, but they're excellent talks that go through these 3 options. And the key is, again, the same. You're using the same tooling, the same APIs across the board, and wherever you run Kubernetes, and then you get the same primitives without having to relearn. And I think that is the broader theme I want you to take away from a lot of these services that are being built. So when we say we build tools for multi-cloud, a very key aspect of it is it has to support these open interfaces. So which brings me back to the end. So we spoke about Walmart's journey. We spoke about customer A, who first meshed and then containerized. And then we spoke about customer B, who actually first containerized and then meshed. And imagine that there are 3 or more other patterns where they're not necessarily starting from monoliths. In fact, we have a talk today where we talk about how service mesh is equally applicable to telco workloads. So one of the key things about these technologies is they don't really make assumptions about whether whether it's VMs, containers, whether it runs in Google or elsewhere. Like, these are very good abstractions from that point of view. And so how to use them and when to use them actually boils down to having a plan. And here are the typical steps that are common across these 5 or 6 blueprints. So when you start your journey to going and migrating your own workloads or even bringing all of these technologies to Brownfield, you have to start with your goals. Like, what are your goals? Why is it that you want to bring in? And hopefully the answer is not just because they are cool, because all of these are extremely cool technologies. But there has to be some business goal, or there has to be something around agility or some problem that it solves for you. And that is the crux of it, honestly. Once you've identified that, then you can map to one of these strategies. We'll have a lot more papers that go out that describe each of these in detail and more. And so once you've identified your strategy, then the strategy will let you choose tools. And that will depend on what is the kind of tool you want. Like, I would say the table stakes is open interfaces. Like, look for open interfaces, because then you can change your mind. You can swap things out and bring in new tools. And these could be Google Cloud tools. These could be third-party tools. Often we have a lot of complementary tools for the problems that you face, and we don't necessarily have a solution. So identify your services and tools. Make sure you've done your due diligence on them. Once you've done that, most of the success stories that we see are customers who've had an MVP use case, which means that there's a set of services they identified, and then they execute the strategy with those small set of services. And then once they see success, they will go and optimize, because obviously they are learnings from their first phase of execution, and then they'll optimize, and it's rinse, repeat. And in all of these, one of the critical bits is essentially to automate, automate, automate. I can't stress that enough, but again, the success stories of making these things repeatable, easy to manage, is that you bring in these CI/CD pipelines. We have customers who manage code in CI/CD pipelines, and it just makes their lives that much easier. So I know it was a bit of a whirlwind tour, but we hope we gave you at least a flavor of the various strategies you can use to bring in service mesh, containers, and modern technologies into your brownfield. So with that, thank you.